Hello and welcome to the next lesson in the STEM Lockdown Digital School. This is Grade 10 Information Technology and my name is Karen Anderson. This is lesson 2 that we're going to be doing today, and in this lesson we're going to be having a look at the solution to the constants activity that I gave you for homework in lesson 9. We will also look at the solution to the gaming activity that I gave you to complete. Then we will have a look at the rules around if statements and all the important things that you need to remember regarding if statements. Then I'm going to show you the ink and deck procedures and explain to you how those work. And then I'm going to give you the take a lot activity as homework in preparation for lesson 11. So let's get started. First of all, let's have a look at what you needed to do for the constants activity. So these are screenshots of the results of input after coding, just to give you an idea of what you might get when you do the program. Let's now have a look at the actual code. So first of all, you needed to be aware of the fact that these constants were in the program declared for you already. They were there for you to use, and you would have had to have used them in your code. This is the kind of thing that is assessed in a test or an exam. If you are provided with constants or you are given constant values in the question paper, and then you rather use 96 or 23.95, you're going to lose marks in that test or exam because you're expected to know how to and to use the constant values. Then onto the code. This is the on-click event of the tissues button, which was the first question. As we've seen repeatedly now, your input was coming in through an input box. So you had to be sure that you had 3 arguments, 3 sets of inverted commas separated by commas. For the input box, you then had to convert it to an integer to put it into an integer variable. Then your calculation to work out how many boxes of tissues, you had to realize that you would need the ceil function. Because first of all, you can't buy part of a box of tissues. And second of all, you would have to go up, because even if you're only using 50 tissues, you would still have to buy a whole box. So your calculation was the number of learners multiplied by the average number of tissues used by a person and divided by how many tissues you find in a box. And that would give you how many boxes to buy. The cost would then be the number of boxes multiplied by the box cost, which is once again, as you can see, a constant value. And then your output was pretty straightforward. We've seen this a lot in all of these lessons, so I don't think I need to go into much detail with that, except for you to check that you did it correctly. And to remember that because cost is a money amount, you would use FF currency to output it, so that you could format it as a currency when you output it. Moving on to the school click button. Now what I've added here is a section of the question just to draw your attention to it, because once again, this is one of the things that happens often is when children are presented with a question or an activity, they don't read it very well and they miss large parts of important information. So in this question, you were specifically told that the school needs space for offices, 2 rugby fields and 3 netball fields. So you needed to calculate how many classes you could build for a certain square meterage. But you had to take into account that there was going to be space for the offices and the rugby fields. Again, you were given constants telling you the size of a rugby field, the size of a netball court, the size of a class, the size of the offices, and the name of the school. And then you had to read in the length and the width of the piece of land. Obviously, then you calculate the area by multiplying the length and the width. And then to calculate how much area you would have to build classes in, you had to take the total area and subtract 2 times the rugby field, because you were told there would be 2 rugby fields, subtract the offices area, and then also subtract 3 times the netball fields. Okay, so that you could then work out what was left to build classrooms. And in this instance, you would have to then use the floor function to take the area and divide it by how big a classroom needs to be, because you can't, first of all, build half a class, and second of all, if you don't have enough area for that last classroom, then you can't build it. So that means you need to round down to make sure that you're going to have enough space for all the classrooms that you want to build. And then once again, you had to output the school constant into the panel's caption, and then you had to output all your other calculations in the rich edit. Then the online gaming activity. This was once again an example of the possible output. You had to get the user to enter their name, surname, and the number of minutes they spend playing games. And then you had to add each person whose information was captured to the rich edit. And the first thing that I pointed out to you when I discussed this activity was to look very carefully at the question at the columns. So there were 1, 2, 3, 4, 5 columns of output, and then there was the summary that came after that. So let's have a look at what the code should look like. So first of all, in the on-click event of the add button, which was where you captured the person's name, surname, number of minutes they spend playing games, and then you had to generate a random grade for them. Then you also once again were given a constant value of the number of available hours, and you had to know that you would have to declare the total and the counter under private as global variables. So your processing then involved taking the number of hours, the hours were calculated as the number of minutes divided by 60, but using div, because we didn't want any decimals, we just want to know the number of hours. So if you had captured 123 minutes, for example, you would say 120 div 60, which is going to give you 2 hours, silly me. And then the number of minutes is going to be the number of minutes mod 60. So again, if we took 123 and we said 123 divided by 60, we don't really care what the answer for that is when we're doing mod, but there would be 3 left over. So therefore, this calculation would tell you that 123 minutes is 2 hours and 3 minutes. So you captured or worked out the hours and the minutes. Then you were told to only add the hours to the total. So you didn't need to do anything with the minutes in any kind of calculation. Then you had to count each name as you added them so that you could put a 1, 2, 3, counting how many of them had been added. Remember, and I will look at it later, you could have also used IncICount if you know how to use it. And then you had to work out the percentage, which was the number of hours spent playing games divided by the available hours times 100, because that's how we calculate a percentage. What out of what times 100. And then the output, you had to use the square brackets 1 for their initials, a full stop and a surname, again something you've seen before, and then your #9s in between each section of information so that it was spread out in columns. So you had the initials and surname, you had the grade, the number of hours, the number of minutes, and then the percentage formatted to 2 decimal places. And then you had to also enable the summary button. In the summary button, you had to calculate the average, taking the total number of hours divided by the number of people whose information you had captured, and then once again, nice and neatly at the bottom, capture all of this output. Then, just to remind you, I've got another picture of the output here with the initial and surname, grade, hours, minutes, and percentage. 1, 2, 3, 4, 5 columns. This is very, very important that you remember this. 5 columns means I must set 4 tabs, because the first one is up against the side of the rich edit. There's no tab at the beginning. And then my tabs are numbered from 0 going up. So I'm set 4 tabs, given them each a value, but because I started at 0, the last one is tab number 3. And then just to show you the headings, as they are here at the top of the rich edit, is going to be initial and surname, grade, hours, minutes, and percentage. Another tip, if you want to use that as well, is if you need to work out how many tabs to set, look at how many times you type #9. There should be a tab for every #9. So I've got 4 #9s, I should have 4 tabs. And remember, you have to start with saying how many tabs there are. So red output dot paragraph dot tab count gets the value of 4. And then you set each of those 4 tabs by going red output dot paragraph dot tab square brackets and the index of the first one being number 0, then number 1, number 2, number 3, and each of them then gets an increasingly larger number to set that tab. And if you have a look again, I wanted to point out to you, this is the onActivate event of the form. This is the reset button. All of this code has been copied from the onActivate event of the form and pasted into the reset button, because it's part of setting the program back to what it was when it first ran. And then, of course, don't forget about initializing your counter and your total variable. They have to start from 0. Initializing, getting an initial or starting value. And then the reset button also needs to include code that clears the components. So it takes whatever text is in EDT name, EDT surname, EDT minutes, and clears it, clears the rich edit as well, and then sets the focus back to EDT name. Right, let's get on to today's lesson and the new stuff regarding if statement. So what I have here is the same code twice. But one of them, the top one, you can see, hopefully you can recognize these red lines as the fact that Delphi has a problem with this. Delphi is going to give me, just like the previous lesson, it's going to give me an error. It will not run because it's picked up that there is a problem, which means this is a syntax error. Now I need to have a look and see what is the syntax error. And in this instance, it's the semicolon before the else. Okay, you cannot have a semicolon before an else because, and this is important to remember, and you can see it from the color here, every line of Delphi code ends in a semicolon. So this first one here, I guess, gets the value of SED guess dot value, semicolon. That's one line of code. And if then else statement is also one line of code. We type them underneath each other to make it look neater. But in actual fact, this is one line of code. And that is why there is no semicolon before the else, because then I'm separating it into 2 lines, and that's wrong. It would be the same as if you put a semicolon in the middle of one of these lines. Okay, so no semicolon before the else. And you'll see just now what that means is you need to concentrate when we start with begins and ends. Okay, So let's have a look at a few more rules or a few more things to bear in mind when working with if statements. So first of all, try, and it's not always easy because very often the processing and the output both have to happen in the if statement. But where possible, keep your input, processing, and output separate still so that you can see what's going on. Another good habit to get into is start the condition with the variable you are testing. Now what that means is rather go if I num is greater than 10. This one over here next to it under the red, if 10 is less than I num, is the same. It's the same as this first one here, but it's just feels wrong and it's a lot more difficult to try and work out exactly what you're trying to say there. So rather start with if variable and whatever your condition is. Okay. To calculate if a variable is greater than or equal to, you have to put the greater than sign first. So it's got to be if I mark is greater than or equal to 80 then. You cannot say if I mark equals or is greater than 80. Okay, that's not allowed. It will give you a syntax error again. Then, when you are dealing with real values in if statements, you have to think very carefully. Because if you're dealing with an integer, as we've discussed before, and I had to say if I number is greater than 59, then you know that it's going to be 60 and higher. Whereas with real values, we've got lots and lots of decimals that put a spanner in the works as far as that's concerned. So if you say for a real number, if it's greater than 59, then 59.001 is going to cause your if statement to be true because it's bigger than 59. So be very careful when testing real numbers to make sure that your conditions are correct. So if you have a look at some examples here, if I said if R mark is greater than or equal to 60 then, or if I mark is greater than 59, or if I mark is greater than or equal to 60. So all of these are correct. If you're using your real for R mark, it must be greater than or equal to 60. You can't just do greater than 59 like you would for an integer. But you can also say if greater than or equal to 60. You cannot say if R mark is greater than 59 because then it's going to take 59.00001 and up. And if you're looking for higher than 60, then your code is going to be incorrect and you will have a logical error. Right, the single line directly above the else doesn't have a semicolon. That is what I showed you in the example. This is one line of code. Then you need to be aware that it's possible to do calculations in your if statement. So it doesn't just have to be if I num is greater than 5. You could have if I num 1 plus I num 2 equals 4. You can put a calculation in your condition that you are evaluating. Then, I have mentioned this before, but let's formalize it and make absolutely sure that you know what's going on. When you have more than one line of code that needs to be executed as a result of your if statement being true. So if R mark is greater than or equal to 80, I want to ink the counter and output it to the rich edit. Then I have to have those two statements between a begin and end. Okay, and what you do is you indent the code to make it more readable and make it easier for anybody that's looking at your code to see that those are the two lines of code that need to be executed if R mark is greater than or equal to 80. Then your else, same principle applies. If you've got more than one thing that you want to happen as a result of the else being true, then they have to have a begin and end around them. And then it's the end above it that doesn't have a semicolon. So whatever line of code is before the else, that is what's going to have no semicolon. Then another tip to help you read your code and to help other people read your code is use comments to indicate where everything is. So over here you can see I've put a / to indicate a comment, and I've typed if to show myself and anybody else that's reading my code that this end belongs to this if, and this end belongs to the else. Because once you start writing code with if and loops and all kinds of things, and you start having lots of begins and ends, it can be quite difficult to tell which begin belongs with which end, or which end belongs with which section of code. So get into the habit now of putting comments in that will then help you to keep track of what your begins and ends are. Okay. Right, so I've put this in here because I want to show you two things. So first of all, not only can you have a calculation in an if statement, but you can use a function in an if statement. So this over here has got the date property of a date time picker that's been put into a dDate data type, remember, of type tDate. Then my if statement says if year of dDate, remember we've done that function, it extracts the year from whatever date I got from the date time picker. If year of dDate is greater than 2020, then this year is in the future, at least for now. If you watch this next year, maybe that's not true. But just to give you an idea of what's going on here. The other thing that I want to point out to you with this code is, if you put a begin and end when there is only one line of code, it's not wrong. So your program will still work, it will still do what you have to, and you wouldn't lose marks for putting the begin and end in for just one line of code. For me, it's actually a personal preference that my students do put that begin and end in, because if you get into the habit of reading out your if statement as if year of dDate is greater than 2020, then begin, then you will always remember to put the begin and the end in. Because if you don't, that's when things get disastrous, and that's when all kinds of logical errors creep in. So if you get into the habit of putting in a begin and end for just one line of code, that's fine. Okay. Then this one over here, what I want to show you on this sample code here is, if you're testing if something is true, you don't have to include the value true. So this is almost the same code, except that I've included another function in here. So here I've got a function inside another function. So I've taken my year of dDate, like the previous one. So that's going to return whatever year it is for the particular date selected in the date time picker. And I then apply the isLeapYear function to that, which means I'm wanting to determine whether whichever year was selected in the date time picker is a leap year. So I can say if isLeapYear, year of dDate, equals true, then output you have chosen a leap year. Now what I want to show you is that this equals true is not necessary. You can just have your if statement look like this. If is leap year, year of dDate. So the equals true is gone. It's not necessary. It works exactly the same way. Right, now we move on to inc and dec. Now inc, as you can see up here, will accomplish the same as iCount gets the value of iCount plus 1. In other words, inc is to increase the value of the variable in the brackets. Remember, this is called an argument. So inc will increase the argument in the brackets. Dec will decrease the argument in the brackets. So it's the same as saying iCount gets the value of iCount minus 1. So let's have a look quickly at some sample code so that you can maybe get an idea of what's what here. So here I've got, I guess again, that I'm reading in from a spin edit value property. So I'm getting a user's guess. Then I'm saying if I guess equals I number, so I'm checking if those two equal each other, then show message correct, well done, and ink I points. In other words, I want to add to the number of points that this person has for this guessing game. And there I've put my comment in to indicate that that's the end of my if section. And then over here is my else section. And here I've got deck I chances. In other words, this program was written so that they only get so many chances to guess what the random number is. And every time they get it wrong, I am decreasing the number of chances that they have. So let's say, for example, they have 3 chances at the beginning of the game. And now when they've guessed and they've got it wrong, it's going to take 1 away from I chances. So now they only have 2 more chances to try and guess what the random number is. So that's how ink and deck work. Then, this is very, very, very important, and I'm hoping that all my bright colors and my highlighting and all the rest of it, and the red writing is going to get this message across. Ink and deck are procedures. Now, as of yet, you haven't really officially come across procedures. Most of the methods that you've looked at are functions. But now you're coming across your first set of procedures, although show message could possibly be seen as a procedure. But what being a procedure means is that it is called on its own. So when I call ink I points. That's it. I do not go I points gets the value of ink I points. Ink cannot be part of a gets the value of sign. Okay, it's not a function, it is a procedure. It stands on its own. So please, no red highlighting. Don't do this. This is incorrect. Okay, so if you try this, it's going to once again give you a syntax error, and then you are going to get all flummoxed and confused as to what you've done wrong. Not this. Please, please, please remember. Some more rules. Ink and deck only work with integer and char values, and I'm going to explain a little bit more to you about what integer and char data types are in the next lesson. So if you use a char variable in ink, it's going to change the character to the next one in the ASCII table. And if you use deck to change it, it's going to take it to the previous one. Now what I've done here is I've included the ASCII table. So hopefully you've come across the ASCII table before. It's a table that has a decimal number that represents a whole series of different characters that you can use. And you can see here that the ASCII value of a capital letter B is 66. The other thing that I just wanted to point out to you as a matter of interest in this ASCII table is if you have a look on the left-hand side here, you'll see that number 9 says HT next to it. Now that HT stands for hard tab. So that's where your #9 comes from when you want to put in a tab. The one above it, which I haven't highlighted, which is #8, is a backspace. Okay. 10, which I showed you, #10 puts your output onto a new line, is LF, which stands for line feed. Okay, and #13, which does a similar thing, almost exactly the same for your intents and purposes, is CR, which stands for carriage return. So I just wanted to show you that these numbers that we're using, #9 in your code, is actually, according to the ASCII table, a tab. And the other one that I wanted to show you just for interest's sake is number 32 on the ASCII table is a space. So if you typed #32, it would be the same as saying plus a space in inverted commas. Okay, so just out of interest. Right, let's carry on with here. Because it does the same as iCount gets the value of iCount 1 or iCount gets the value of iCount minus 1, your argument must be initialized. So the value that you put in the brackets after inc or dec must still be initialized because it's using still the same concept. I'm adding to something. I'm saying what's in iCount minus 1 or what's in iCount plus 1. So therefore I have to have a what's in iCount, whether it's 0 at the beginning of the program or 12 after the program has been running for a while. So remember, inc and dec still require you to initialize whatever value you're putting in the brackets. And then by default, when I say inc iCount, it goes up by 1. If I say dec iCount, it goes down by 1. But if I want it to go up or down by a different value, I can include that after a comma in the brackets. So if I went inc iCount, comma 5, it's the same as saying iCount gets the value of iCount plus 5. If I said dec iCount, comma 2, it's the same as minusing 2 from iCount. So also, I just want to point out to you, when you're, let's stick with inc, although it works for both of them, this argument over here has to be a variable. I cannot say inc 10, comma 5. Because where's the 15 going to go? It has to be put back into this variable here, which means that this has to be a variable. The one after the comma can either be a value like this, like 5, or it can also be a variable value. So I could say inc iTotal, comma inum, and it would add what's in inum to iTotal. Okay. ASCII chart we've looked at, and now let's have a look at what you need to do for homework. So in the Dandelion Delphi book is an activity called if statements. You need to open the program. It's in the if statements folder. Again, at the end of this slideshow, I will show you where you can download the files, and then you're going to look at the take a lot menu option. We've used the menu options before. You're going to look for the take a lot menu option, and I just want to point out some important things that you need to take note of in this question. So it says make use of a dialog box to ask the user to enter the description of a product they would like to order. And then you have to use the name of the item that you got in the first dialog box when you ask for the price of that item in the second dialog box. So the user entered divergent series when they were asked what they wanted to buy. So the second dialog box pops up with enter the price for divergent series. So you have to use what you got from the first one and put it into the second one. Then you need to keep track of the total amount ordered and the number of items bought. So there's your counter, counting how many items were bought, and also then calculating the total amount ordered as a running total. If it's the first item bought by this customer, clear the reg edit, set up the tab stops, and display the heading. So that's important. You need to think about how you're going to determine if this is the first item that the customer has bought. And then display the item number, item description, amount, and total amount owed so far. So again, you're looking at the output. You've already been given a clue here that you have to set tabs, and you're going 1, 2, 3, 4 columns, which you should already be shouting out to me. That means that you will have to set 3 tabs. Then for the checkout button, you have to store the input from the user from the edit to indicate their profession. If they're a student, they receive a 5% discount on the original total. And you have to ensure that your program is not case sensitive. Now, this again can also be a very confusing thing to think about. So I'm going to explain it to you. I have said to you all along in these lessons that your Delphi code is not case sensitive. So if we go back to this code over here, if I typed I guess with a lowercase g and I number with a lowercase n, my code would not have a problem with it. Delphi is not going to have an issue with me using uppercase or lowercase or whatever the case may be. But when it comes to what is inside a string variable or a string value, then that is case sensitive. So as far as Delphi is concerned, this line here, correct exclamation mark, well done, 2 exclamation marks, is different to lowercase c for correct and lowercase w and d. So the contents of a variable is case sensitive, and I'm going to show you why. It all goes back to our ASCII table. If you have a look at the ASCII table, remember what your computer is doing is it's looking at a letter, it's converting it to the decimal value and then converting it further to a binary value, because your computer only works with ones and zeros, or current and no current. Something's either on or off. So if you have a look at your ASCII table here, capital letter A has an ASCII value of 65. Lowercase a has an ASCII value of 97. That's 2 different numbers. So that's why when you are dealing with strings with Delphi, it will see an uppercase a and a lowercase a as 2 different things. And that is why this question over here, when it says ensure that no matter how the user has typed the word student, the program is not going to be sensitive with it. And what you have to do here is you need to use the uppercase function. Now, if you haven't used the uppercase function, I will show you in the next lesson how that works. Okay, so if you don't know, you can either look it up at the end of the book, or else you can wait until the next lesson and then I'll show you how to do it. Then you need to keep track of this discount. If they spent more than 1,000 Rand on their order, they're going to get a further 10% discount. They get a delivery for free if they ordered for a total of 450 Rand or more. Otherwise, there's a 60 Rand delivery fee, and your VAT is calculated after the discount has been deducted, and there is no VAT paid on the delivery fee. So you've got to read these questions carefully to work out exactly how you need to perform your calculations. And then finally, you are going to calculate and display the final total as with these examples. Okay. Then the numbers activity is also in the if statements program, but it's on a different menu option. So here you have to store and display a random number from 1 to 100, and then you have to test, count and display if the number is odd or even. Now there are various ways of using Delphi code to determine if a number is odd or even, but again you need to think about the logic. What is an even number? An even number is a number that's divisible by 2 with no remainders. So mod is going to be very useful. If a number mod 2 equals 0, then that number is even because the remainder is 0. It was evenly divisible by 2. See the word play on words there. If it's an odd number, you need to calculate and display the percentage of odd numbers selected so far and do the same for the even numbers. Then you have to test and display if the number is a multiple of 3, and then also test and display if the number is a factor of 60. And after 4 clicks, 4 different numbers have been output, and this would be a sample or an example of the output. You wouldn't get the same thing because the numbers are being generated randomly. Both of these activities, I will go through the solutions to them in the following lesson. So what have we learned today? We've learned that if statements are used when a program must make decisions. So if your program needs to choose one or the other series of code to execute, with an if statement, it's never going to execute both sections of code. Then you're going to put in an if statement. There are rules that you've got to follow when you use if statements. Inc and dec are procedures that increase or decrease an integer or char value, and you must do the take a lot activity for homework, and what I haven't included in here is you need to do the numbers activity as well. Right, as promised, the book that I'm using is called Dandelion Delphi Book 1 for Grade 10 Information Technology. If you can go to this URL here to purchase the book for 70 Rand. You must download the data files from this URL so that you can actually work through the activities that I'm working with. And then you need to visit the Africa Teen Geeks website on a regular basis to sign up for the schedules, and also you can access the PowerPoint presentations. These ones that I'm using for my lessons, you can access on the Africa Teen Geeks website. So if you want to, you can then download the PowerPoint presentations and go through the work again on your own if you need to. Next lesson, I'm going to have a look at ordinal data types and what ordinal data types are. I'm going to look at the length function. I'm going to look at some validation techniques which use other functions, including, as I mentioned earlier, the uppercase function. And then we're going to look at the in operator used in if statements. And as I've already said, we will also go through the solutions to the 2 activities that I've given you for homework. Please don't forget to follow us on social media and visit the Africa Teen Geeks YouTube channel on a regular basis, because these lessons are being uploaded for you to go and visit and watch when you have a chance or when you need to double check on something. Thank you for listening, and I hope you've learned something. Goodbye.